Welcome to this lesson. In this lesson, we are going to be looking at application programming interface. So, we'll be looking at what an application programming interface is. We're going to run through history, how API has evolved, and where we are in application programming interface. Then, we're going to be looking at using this programming API to actually work, using API in Reactjs to integrate it to a backend application, right? So we built this login and sign up page in our last lesson. And so what we are going to do now is that if I click on this, if I enter a username and password, you can see. Then if I click on login, we're going to get invalid username, email, and password. So what we have done now is to integrate this our login page to our backend login API. And then we're able to determine if a user is actually a valid user or not. So we're going to take off from our last lesson to actually integrate with a backend application, a login API, for authentication of our users, right? So meanwhile, please, if you have not subscribed to our YouTube channel, just click on the button below to actually subscribe so that you can get more content like this, right? So what is an application programming interface? So let's break it into 3 words: application, programming, and an interface. So an application is a service assembled by a human being or computer program, right? So for example, your Facebook is an application. So any application or any service that's assembled by human or computer program is an application, right? And a program is a set of instructions written by a developer to perform a particular task, right? Then an interface makes a connection between 2 things. In our case, between application and program that use it, right? It defines what a program can request from the application, transmit program requests to the application, and application responds back to the program. So a typical example of what application programming is let's cite a scenario of a television, a remote control, and then a user. So the remote control is the interface, and the user is the program. The television is the application. So an interface is now in terms of contract defines a contract between how the television and the user, who is a program, actually communicate. So the remote control is the interface, and the television is the application, and the user is the program, right? So I think it will be better if we look at so an application programming interface is a way for 2 or more computers or components to communicate with each other. So it's a type of software interface offering a service to other pieces of software, right? Interface can be thought as a contract of service between 2 applications. So when you sign a contract with someone, you define how your terms of contract. So what interface does is to define the terms of communication between the program and the applications, or between two applications. So this contract actually defines how they communicate with each other using request and response. So a document or standard that describes how to build or how to use such a connection or interface is called API certification. Some people call it API documentation, right? So just as remote control is the interface between a viewer to program the solution, an API is the interface used by a programmer to interact with an application. So API comes in different forms. So we have different types of API. API comes in different forms, such as web API, operating system API, database API, and others. All serve to empower developers in building applications that interact with third-party services, access external data source, or expose internal functionality to external developers. So when you talk about web API, you are saying that a web API is an application interface for the web. So any API where the program and the application has to go through the web for communication, is termed as Web API, right? While on the other hand, an operating system API enables application to interact with the underlying operating system. It allows application to access essential OS services and functionalities, right? So we also have the database API. So database APIs enable communication with an application and a database management system. So we also have the remote API. Remote API enables communication between software component and application set over the network. So to appreciate this, let's boil down to history of how APIs evolve with time. So an API in the most basic sense is a set of rules and protocols that defines how software components should interact, right? So in building application, an API simplifies programming by abstracting the underlying implementation and only exposing object to action that the developer needs. So let's look at the case, in the case of this television and remote control, which we are using as to actually explain API. Now, when you are using a television, you want to tune to different channels. Now, you don't have idea how the content is being developed. You don't have idea of how the content is being broadcasted. All you want is information on, for example, the current day news or what is happening in sports. But the underlying things that happen behind the scene is none of your business. So what API does is to abstract that functionality and just expose to the application or program what actually he or she needs. Now, when you go to your email and then you are requesting for, you are sending an email from one point to another. You are sending an email to a friend or you are sending an email to an uncle. Now, how this email is being sent, what happens behind the scene is hidden from you. At the end of the day, you send an email and then the receiver receives an email. So API, with the help of API, the functionality of how this email is being sent is abstracted and hidden from you. So all you need, all that's exposed to you is a rule of what you should do to actually send this email to the receiver. So that's what I'm saying. An API, in the most basic sense, is a set of rules and protocol that defines how software components should interact. And it also abstracts the underlying implementation and exposes only objects from action that the developer needs, right? So if you are actually building an application, for example, in the case where we're going to be building the login page. Now, what happens behind the scenes? So what the front-end person does is that he enters username, enter password, and then send via an API to a different system. What this system does is to authenticate the user by comparing what is being sent to that application, what's being sent to the database, what he has on the database, and then return back if that user is an authenticated user or not. Now, what happens behind the scenes is hidden from the front end. And so it's abstracted away, that functionality is abstracted away from the front end. And so the only information the front end needs is if the person is an authenticated user or not. Right? So in the same way, you use your telephone channel. And that's also say an API abstract the underlying implementation and expose only those object or action the developer needs. Okay? So I think it will make more sense if we actually look at the history of how API have come, where we started from. But however, we have divided API into different types. We say we have web APIs, we have database APIs, we have remote APIs, we have operating system APIs. So throughout the early 1960s, computers started growing popularity. Organizations will begin to experiment with their uses. So the term API was understood at this time as interaction of a single application with the rest of the computer system. And so the kind of APIs, what was understood as APIs was the operating system API. And what was understood, what's operating system API is a single application interacting with the rest of the computer systems. So API were used to enable communication between mainframes and other systems. So bringing about what we call hardware independence. So a computer, so if a computer or display needed to replace. So if you needed to replace a computer display, it mustn't be the same product or the same type of product with the one you are replacing with. That's because the components of the computer system are independent. So what the operating system API was solving at that time was the hardware independence, where if you are replacing a mouse, for example, a mouse, for example, in our case, a HP mouse, which was the initial mouse that was used on that system, you don't necessarily need to buy the same HP mouse or the same model to replace with what here. That's because with the help of operating system API. And so what it has solved at that time in the 1960s was hardware independence, right? So now, at that time in 1960, the internet was not yet there was no internet, there was no network. And so in 1980s, computer networks started becoming common, and programmers needed to access libraries located both in their local computers and also in a computer elsewhere. So there was a need for a form of API where you can access resource from a computer located in a different network. And so API enabled what we call remote procedure calls that generally supported by Java. So API played a critical role in enabling cross-platform compatibility, allowing developers to create applications that could run on multiple platforms. Now, the 1990s saw a birth of the internet, and API were a way for applications to exchange data with the use of standard set of protocols. And so with the birth of internet, so there was actually a need for us to actually access resources or systems communicate to each other over the internet, over HTTP protocols. And so what we would understand as Web API started from the 1990s. So, and what we define as Web API? It means, when you say Web API, it means for software components to communicate with each other via the internet or via the HTTP protocols, right? So you are leveraging the internet to actually aid communication between two software components. So in 1990 saw the birth of the internet, and APIs were a way for applications to exchange data with the use of standard set of protocols. So APIs were still in their early stages, but they were to pave the way for emergence of web service in the next decade. So in the early 2000s, the internet was taking off, and they were also looking for a way to simplify web development and programming. So Roy Fielding in 2000, Roy Fielding in his PhD thesis actually called the architectural styles and designs of network-based software architecture, define what we call today known as REST. Right? So this is where we are today in APIs, web APIs. And so with the birth of the internet, APIs. Now, what is web API? What is this REST all about? Which is what our focus on today. And this is what we're going to use for our React application. So let us now come to understand what is even this REST. It starts from the positional state transfer. Okay. So if you look at this video, you see at the left hand side we have programming, we have application, we have API. Right? So whatever is within the application is abstracted from the programming. Right? And so for the programming to actually access resource from this application, it has to do it via an API. And so this programming part where the user is actually interacting with has no idea what's going on within the application. And so to actually access resource in this application, the API which is at the middle, which is the interface, defines the rules. So all the programming to do is to follow the rules of the API, and then it can access any resource or whatever you want to access from the application. Right? So what exactly is REST? REST stands for representational state transfer. So if you look at this figure, this diagram, or this video, you see that we have a resource, we have a server, we have a client. This client is trying to make requests to the server. So in the case of programming, application programming interface, client is the programming. Our server is the application, right? So that's trying to compare this with what we define as API. And so let's now look at what REST means. We have a resource, and only the server has access to this resource. This resource can be information, it can be database, state database, access to information, or whatever data that this client actually needs. So the client makes requests to the server, right? And so these requests made to the server. And so the server in response access the resource, interact with the resource to actually respond to the client, right? So response is given back to the client in form of JSON, right? So this response is the current state of the resource. And so therefore the word representational state transfer, in other words, the representational resource state transferred as response. Do you get that? The representational resource state. So the state of the response, the state of the resource is transferred to the client in form of a response. So that's now without inform the name called REST. Representational state transfer. So the client is accessing, needs make request to the server. The server in response interact with the resource, and the server responds back to the client the current state of the resource as demanded by the client. All right? Okay. So we are going to take this knowledge to actually come to our React application to interact with an API, and then to actually depict if a user is actually authorized or not. So in the case, now we have a database of users, and somebody comes to our client application to put in a username and password to log in, right? So this request is sent to the server, right? And the server has access to the resource. It extracts this username and password from the request sent by the client, and then go to the resource to compare if that username and password actually exists in the database. In response, it returns to the client the current state of the resource. So that informs the name relational state transfer. From this diagram, you agree with me that the main elements of a resource API, RESTful API, are client, server, resource, right? So the main element of a client, server, and resource. And so what exactly is a client? A client is the software code or application that requests a resource from the server. So what application, the application that requests a resource from the server is called the client. The server, in essence, is the software code application that controls the resource and responds to the client request for the resource, right? And so the resource itself is the data or content such as text, video, images the server controls and makes available in response to the client request, right? Now, to access this resource, the client sends the HTTP requests to the server. So what the client sends to the server to access this resource is the HTTP request, which you can see. Now, so client requests include 4 principal parts. So this request sent from the client to the server includes 4 principal parts. The first is the HTTP method. The second is the endpoint. The third is the header. And the fourth is called the request body. So if we look at the diagram, you will see that what is sent to the server has the HTTP, we call it the endpoint, which some people call URL. That's why I'm written the URL there. We have the header, right? And we have the request body. Okay. So what's the HTTP method? This details what should happen to the specified resource. So the 4 fundamental HTTP methods, some text material call it HTTP verbs, are posts, right? Gets, put, delete. So posts, the word post means to create a new resource. The word get means to get means to retrieve an existing resource. To put is to update or change an existing resource. To delete is to delete a resource. So these are standards. These are RESTful standards. So when the intention is to actually create a resource, use the post HTTP verb. When the intention is to retrieve a resource, use the get. When the intention is to update a resource, use the put. When the intention is to delete a resource, use what? The HTTP verb. Now, the second one you have is the endpoint. So the endpoint shows where the resource is located, right? So if you look at the diagram or the video, you're going to see /survey 123. This is showing the location of the server and the service itself, which the client is actually trying to communicate to. So the endpoint shows the location of the resource or the service the client is actually making a request to, and in turn the service has access to the resource. So this /survey is showing the location on the server. The service is on the server. The service itself on the server, and that server or service itself has access to the resource. And so while the header are the details needed to execute the call and handle response. So the request header might include authentication data. It might include encryption key, more details about the server locations or access information, and details about the desired data format needed for the response. So the fourth is the body. The body contains the relevant information to or from the server. For example, the body may contain new data to be added to the server through the post. So if I'm trying to make a request to create a resource, the body may contain the data I'm about to use in creating. I need the server or the server to use in creating a resource, right? Parameters in API, right? So parameters are used to send information from the client to the server. For example, you want to create a resource. The server needs to know the information, the content of the resource you want to create. You want to delete a resource. The server wants to know which particular resource, the ID or the identity of the resource you want to delete. You want to update a resource. The server needs to know the identity of the resource and the new resource you want to update with the current resource, right? So there are four. So parameters are used to actually send this kind of information to the server, right? And there are 4 types of REST API parameters. We have the path parameters, we have the query string parameters, we have the header parameters, we also have the request body parameters. Now, the query string parameters, we can specify them in the query string of the endpoint. A query string is a string that starts with question mark. So, and includes parameters listed one after another. So in your endpoint, or what you call your URL, you can see we have this as question mark guess equal to. So what it means is that we are sending a path params of gets, and the value of that guest is 3. And you're also sending a path parameter of days, and the value of these days is 2. You're also sending a path parameter of time. The value of this time is 1400. So the server can extract these path params these path parameters of guests. So there are 3 path parameters sent to the data. I mean, there are 3 things sent to the server, and their name include guests, day, and time. And the value of guest is 3. So the server can extract guest as 3 and make use of it as defined within the server environment. The other type of parameter is the header params. These parameters are included in the request header. So in the header that is sent to the server, that is where these parameters are actually included. So the other type of parameter is the request body parameters. So the request body parameters are used when clients send data to the API. Generally, the parameters are shipped in the form of JSON object, right? And specifies the content, right? So in our case, we are sending in the case of header params, in the case of query params, we are sending data to the server via a query string. The same data can be sent to the server via a request body. In our case, it's a JSON object attached to the body of the request. As a software developer, you will need certain tools to actually test APIs before you actually implement them in your project. One of it is Postman. So it's either you can download Postman. I have Postman on my desktop downloaded, but I want to use that of the web. So you can use Postman. You can download Postman. All you need to do is to go to Google, right? And look for, and I'm going to search for Postman, right? So click on Postman, right? And then, okay, I'm signed in already. You can download Postman, right? Can click on download Postman, and then you can download Postman and install on your system. So you can use Postman as a desktop application, as a desktop application on your system connected to the web. You can use Postman as a web application. Me, I'm using it as a web application. On that tool, instead of Postman, you can also decide to install using Thunder clients. You can see this Thunder client on your Visual Studio Code, right? So all you need to do is to go to Visual Studio Code extension and then search for Thunder client. I have it installed already, and then you install it. Once you install it, you have this symbol, this Thunder client symbol on your Visual Studio Code. Click on it, and then you can test. So instead you use Postman. So what we are doing is that using Postman or Thunder client, they are now serving as the client side of it. So you are trying to make requests to your server using Postman or Thunder client. So I'm going to go back to my Postman, right? Okay. Now this is the endpoints, and as we said, the endpoint defines the location of the service itself. In my own case, I'm trying to make a transaction to Paystack. Paystack is a payment gateway for making payments. So if I'm building an application that has to do with making payments, where, for example, you build an application where you want your customers to make payments to you for a service, right? So you need to integrate to a payment gateway. And in this case, I'm testing it with Paystack, right? So all you need to do is go to Paystack, and then create an account, and then after creating an account, you have access to an API key that you can use in making requests, right? So I will do that in that video on working with Paystack, working with payment gateways such as Paystack and other payment gateway, InterSwitch, and the rest of it. So this is the endpoint, but in this case, we're talking about API. So this is the endpoint. And don't forget, I will say that the endpoint contains elements of endpoints are your request body, your header, the endpoint itself, right? So this is the endpoint and defines the location to the service, right? And this endpoint is used to initialize payment. So this is the first endpoint you call the Paystack when you want to make payment. And this part is our HTTP, which is post, which is the HTTP verb or method. Post, get, put, delete. We also have patch, header options, right? So in this case, we're making a post request to our Paystack gateway. And then this is the header where we define the header parameters. You can see them. You can define your header parameters here, right? You can define your header parameters here. So, and And this is the body where you can define your body parameters. Those. So in our case, we want to send an email and the amount we want to make payment to our Paystack gateway, right? We want to make that request. So we are sending the email, which is the email of the user that want to make a request for, that want to make payment, and then the amount the user wants to make payment for, right? Okay. So and it's a post. So once you set it, you actually click on send, and then the Paystack. So the server returns a response, and so the response the server returns is telling us the response was successful, which is true. Our status code is 200 here, which means that the request was successful, and then it returns to us the direction URL, which is the URL you should make the payment to. The client should redirect to for the payment, which we will see. Then the reference number, which is reference code for the payment and access code, right? So if I take, for example, this URL now, and paste on our website, our website, look at where it takes us to. It takes us to Paystack for us to actually make that payment. So we'll make a request to the server, and the server returns a response from us. Part of the response is the URL where we should redirect our client to make payment, right? So we're not talking about Paystack. Paystack will be another lesson on its own. But then what we have established is the fact that we're able to make requests, send requests to our server. Our server has access to the resource, and then our server responds back to us a response, which is what we actually need, which is the state of the resource which we actually need. And that response is the current state of the resource. So which is the response we actually need to carry out further actions in our applications. Okay. So we are now going to take this information, take all this piece of information, and then go to our login page, which we have created in the last video, in the last tutorial, to actually integrate with our backend endpoint, with our backend server to actually enable login on our interface. So users should be able to log in, right? Which is what we have actually done here. So if you enter a wrong username and password, you click on login, it actually communicates with the backend endpoint, and then the backend endpoint has access to the database. It checks if the user is an authentic user or not, and then return response back to the client. And so based on this response, we're going to take it further from there to actually implement our front-end logic.